Hello and welcome to this demo on automated logging for Kubernetes using Telemetry Pipeline. In this demo, you will be taking a look at routing logs from a Kubernetes cluster to two different destinations using a telemetry pipeline. Let us take a look at our demo environment. Here we have a Kubernetes cluster with a core instance deployed. Notice the highlighted pod. A core instance is required to register a Kubernetes cluster and associate it with a telemetry pipeline. Creating a core instance is the first step in deploying a telemetry pipeline. In the UI, I now go to the core instance settings, expand the Kubernetes namespaces section, and then click on Automate Logging. I am now provided with multiple destination options to choose from. Let us begin with something simple. Let's go with printing logs directly to standard out. I click Save and I am all set. I can now see my logs being gathered automatically and listed by my chosen destination. Now, let us take a closer look at the pipeline. In this pipeline, there exists one source and one destination. The source is all Kubernetes cluster logs, and the logs are being routed to standard output. Switching over to my terminal window, I now see a new pod has been spun up. This pod has the same name as the pipeline. Taking a look at this pod's logs, it looks like it is streaming the cluster's logs. This makes sense, since standard output was chosen as the destination. Standard output is convenient for a quick test to verify if your pipeline works as expected. Let us make things interesting and try adding another destination. Select the Forward Destination option. The Forward option allows you to connect multiple pipelines together, making it possible to route logs between pipelines. Consider this example. Say I would like to send the output of this auto-logging pipeline to another, more complex pipeline. Creating a forward destination will allow me to do so, as shown in this architecture diagram. Great, let's see how this goes. First, I create another pipeline in the same core instance. Let's call this Demo Pipeline and set its service type to Load Balancer. Using the Load Balancer service type will allow me to connect to this pipeline from Pipeline 1. Great! Now let's add two destinations. The first one will be Chronosphere logs. The second one is going to be Splunk. Next, I will add a forward source. This source is created to receive data from the forward destination of our automated logging pipeline, aka Pipeline 1. Let's use default values and click Save. Finally, I will also create a post-source processing rule. Processing rules allow me to manipulate log entries. Here, I will create a processing rule that defines a key value pair for the purpose of identifying where these log messages originate from. I set the key to source and provide a value of auto-logging. Click Apply. Apply processing rules. And then save and deploy the pipeline. Switching over to the terminal window, there is now a new pod named Demoinst-Demo Pipeline. I can also see a load balancer service named Demoinst-Demo Pipeline-TCP and the port the service listens on. This is going to be the host for the forward destination in the autologging pipeline. So I'll copy this to my clipboard now. Switching back to the autologging pipeline, aka Pipeline 1, I will now add a new forward destination. Set the host value to the load balancer name that was just copied, click Save, and save and deploy. Finally, if I go to Chronosphere and search for log entries with source equal to auto-logging, I am able to see messages coming in from the auto-logging pipeline. And there it is. an automated pipeline that routes logs from a Kubernetes cluster to 2 different destinations, all done in 5 minutes. That concludes this demo. Thank you for watching.